Hello, everybody. My name is Matt Rosenbaum. I'm the Director of Sales for LP360 Drone. Today, I'm going to show you a quick workflow on how we import the data from a DJI L1. We're going to upgrade that LAS from 1.2 to 1.4, separate that data into strips and assign a point source ID, as well as trim the LiDAR down from an 80-degree field of view to a 60-degree field of view to get rid of some of that noise on the edges of the swath. So first thing we're going to do when importing the data into LP360 Drone is import a cycle from a guest sensor. Since we aren't using a true view sensor here, we're using a guest sensor from the L1. We will select that here. And we can also import data from the DJI Phantom 4 RTK as well as the P1 payloads if you are looking for a photogrammetric workflow through a software like LP360. We'll click next here, and this is where we'll grab the raw flight folder from the ZenMuse payload. So we'll navigate to our raw folder, select it here. Then it's going to grab the data from the DJI Terra folder. We'll navigate to the LiDARs folder, click select, and this will populate everything, including bringing in our images. We're going to select to add a Terra LAS layer to the map. This is where we can have its own specific layer for this, so we can actually compare it to what we do to the data down the line. We're going to name this LinkedIn Demo 1. Click next, and we'll describe the site as a rail site. We're going to call it LinkedIn, and this is where we'll select our coordinate system. This was in Alabama West. Click finish, click yes, and it'll actually import all the data for us, including our imagery, our trajectory file, our SBET, as well as the DJI Terra LAS. So we'll give it about a minute or so for it to get everything importing. You'll actually see this on Google Earth background image, so you can actually see the site and where you were flying and have some references on that. And the first thing we'll do once it gets loaded is we're going to actually separate the data into its own flight lines. So it should have just about a minute or so more, about 30 seconds or so, and there it is. So now that we have our project, we actually see our trajectory, where the drone, including the calibration it flew before the mission, and it's all the trigger events from the images. I like to turn a lot of this stuff off once I get going. But before we actually compute our flight lines, I like to measure the shortest flight line. In this case, this one that we see here, it's about 450 meters. So I'm going to put, when we are computing our flight lines, probably make it about 375 for our shortest leg. Compute flight lines. You'll notice that it still did grab this transit line, so we'll just want to get rid of that before we actually start to create our trajectories. So we'll work from left to right up here on this toolbar. We'll start creating our trajectories here, and this is going to assign the data to the strips, including updating the EXIF data for the imagery, so adding the omega phi kappa and the PPK data to the imagery. So while we're actually, if we do want to click on a point on the point cloud, it'll actually pull up all the images that were in that same location of that point cloud as well. So it's a great little inspection tool here. And it's going to assign each strip a point source ID starting from left to right, in this case, this being our first flying here. So we'll create our trajectories, click yes, give it about 30 seconds. And then once it's done here, we'll actually be able to geocode the new point cloud. And I'll show you some of the big benefits of it after we're done with that process. Like I said earlier, as many of you probably know, the L1 can get inherently noisy on the edges of the swath because of the distance away from the scanner. So we usually like to trim that data down from an 80-degree field of view to about a 60-degree field of view or 30 degrees off nadir. So we'll clip that LiDAR, since we are re-geocoding the LiDAR with the new point source ID. We'll clip it to about 30 degrees off nadir, and we're going to promote that to LAS 1.4. Click geocode LiDAR, and it'll go through, take another about 20 seconds or so for it to complete. And I'll show you the biggest differences between the LAS created from Terra to what we were just able to create within LP360 Drone. So this is our new point cloud. So we'll go back to the beginning. This is the point cloud straight from Terra. Turn off some of these layers to clean up our plan view a little bit. And if you'll notice, if I change this to point source ID, you'll notice this whole point cloud is white because there's no information assigned to each one of the strips. What we're able to just create with the new point cloud is assigning a point source ID to each one of those strips, and I'll turn it again. So you'll see now we have strip 1, strip 2, strip 3. And the big benefit of this now is if there's any misalignments between the data, between the flight lines, we can address those and realign those if needed. If we cut a cross section in a location like here, we'll pull up the new cross section of this site, and I'm going to separate it, go back to point source ID as well here. So we'll navigate to this edge right here, and you'll notice for this is the new point cloud created from LP360. This is the original from Terra. So you'll notice the data comes out over here, and it starts to alligator effect over here, get a little bit noisier over here because of that edge of that swath. We'll make sure that our profile is smaller, and we can actually cut a trend line across this, and you'll see how it's super noisy here, and this is the trend line for the whole point cloud. But when that strip ends, it gets less noisy because you know, it's just one strip, not overlying on top of each other. If we switch back to the new one, you'll notice in this case we just have one point cloud, so it's not nearly as noisy on this, even before doing any alignment of the data. But if I zoom back out, you can see as you zoom in to where the strips do overlap over each other, that the middle strip and the far right strip aren't aligning on top of each other. So there is some differences between the data here. So our next part of this series will actually go through the strip align feature and what it does and how it aligns that data within the software. But just from upgrading it to LAS 1.2 to 1.4 and assigning a point source ID to the data, we're really able to start analyzing the data from the DJI L1 and addressing anything we need from there moving forward. Thank you for joining me today. I really appreciate it. I look forward for you to hop on again on the next series. I'll try to post these every couple of days or so you can actually see how we're able to enhance the data from the DJI L1 within our LP360 drone software. Thanks, everybody. Look forward to speaking with you.